Hi my dear students, this is Suhasini. So today we are going to see representation of function and types of function. So before going into the video, already I have uploaded exercise 1.3, first 5 sums one video and next 5 sum other videos. So both videos link I'll give in description box. So make a notes. Okay. So now we'll see representation of function. See, there are 4 types of representation of function. So first is set of ordered pairs. So set of ordered pairs. Set of ordered pairs is the set f is equals to x comma y, where y is equals to f of x and x belongs to a. Of all ordered pairs represent a function, which means writing the x or y in the form of commas. Like if I give you an example, you'll get to know that is x comma y, and they'll give y is equals to some f of x. So f of x formula they'll give. So y value will be equal to that f of x. You have to substitute and find y value. Then you have to write it in the form of, write the function in the form of x comma y. Okay. So next I'll give you an example, then you'll get to know. So that type of representation is called set of ordered pairs. Okay. So next is the table form. So table form is the value of x and the value of their respective images under y under f can be given in the form of table. So f and the function. So x and the function's value. So both it's given in the table format. So it is written in the table format, then it is said to be as what? Table form. Okay. For this also I'll give you an example. So now next is an arrow diagram. See, arrow diagram you have known. So arrow diagram indicates the elements of domain of f and the respective image by the means of arrow. So domains are given here and their respective images are shown in arrows. So next is an graph. See, graph also you know. The ordered pairs in the collection of f is equals to x comma y, where y is equals to f of x and x belongs to a. Okay, so all the points are plotted in the x and y plane. So you'll draw x axis and y axis, you'll substitute the value and find y value. Then x and y you'll plot in a graph and make a graph. So this is graph representation. So a function can be represented in a 4 method. One is set of order, that is x comma y, and other is table x y. Okay, table format you'll represent. The next is arrow diagram. So arrow diagram you know. So next is the graph representation, x and y axis. Okay, so now we'll see an example. So in this example, I'll show all these 4 ways of representing the function. Okay, so first what we'll do, whatever the elements you have in A, substitute those elements in the place of x, and take the f of x value. Okay, suppose first you have 1 here. So f of 1 is equals to 3 into 1 minus 1. Okay, so 3 ones are 3, minus 1 is what? 2. Okay, so next is 2. So f of 2. So f of 2, 3 into 2 minus 1. So 3 2s are 6. 6 minus 1 is 5. Next, f of 3. That is 3 into 3 minus 1. So 3 3s are 9. 9 minus 1 is 8. So now you got your f of x value. Okay. So first, what is the first representation of function? It is set of ordered pairs. So set of ordered pairs is your first way of representing the function. So how will you represent? Very simple. That is, you have to represent in the form of x comma y, which means, so what is your x value here? 1. When x is 1, what is your f of x value? It's 2. Okay. So then when it is 2, the f of x is 5. Then when it is 3, the f of x is 8. So this is how you'll show the function in set of ordered pairs. Pair form you will show this. Okay. So next is table form. So next way of representation is what? Table form. So you have your x value here and f of x value here. So you have to make a table here. So when your x value is 1, your f of x value is 2. When your x value is 2, your f of x value is 5. When your x value is 3, your f of x value is 8. So this is how you will show the table form. Okay. So now we'll see arrow diagram. So now we'll see arrow diagram. So how we will represent arrow diagram. So first, so what all your a value and all the b values will represent here. So what are the a values here? 1, 2 and 3. So what are the b values? 2, 5 and 8. So you will show the arrows. So this is how you'll draw an arrow diagram for these a and b. Okay. So next we'll see graph. So graph is nothing but you will plot x and y axis. So let's say this is your x axis and this is your y axis. Okay. So x axis and y axis. Okay. So this is your 0. Let's say 1, 2, 3, 4, 5, 6, etc. Then 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is our, see in this table if you see you'll get it. So when your x is 1, y is 2. So when your x is 1, y is 2. So this is 1 comma 2. So then when your x is 2, y is 5. When x is 2, y is 5. Somewhere here, this is 2 comma 5. Okay. Then when your x is 3, your y is 8. So when x is 3, y will be 8 somewhere here. It's 3 comma 8. So mark a line over here. Got it? So this is how your graph will be. So this is the 4 way of representing the function. So what all are those? Set of ordered pairs, then table form, then arrow diagram, then graph. Got it? Okay. Now we'll see the types of function. Okay. So types of function. So in this also you have 4 types of function. 1, 1, many 1, onto, into. Okay. So now we'll see 1, 1. So what is 1, 1 function? See 1, 1 function is also called as injection. So remember this. So 1, 1 is also called as injection, and a function f from a to b is called as 1, 1 function if distinct element of a have distinct images in b. Simple. So distinct elements in a have distinct images in b. Very simple. See, when this is a and this is b, so a elements is 1, 2, 3 and b element is 4, 5, 6. So direct mapping, that's it. So this is your a and this is your b means. So 1, 2, 3. So 1 belongs to 4, 5, 6. So 1 gives 4, then 2 gives 5 and 3 gives 6. Which means all the elements in A will have their respective images in B. Unique respective images in B. So direct images. So this is called what? 1, 1 function. Okay. So each element has their each image. That's it. So next is many 1. Many 1 function is nothing but a function f a to b is called many 1 function if 2 or more elements in A have the same image in B. Okay. So suppose you have 3, right? So for 3 also the image is 5. Okay. So what happens? There is no any 6 here. Again for 3 also the image is what? 5. So this is what they are saying. If 2 or more elements in A have same image in B. So for 3 also 5 only the image, and for 2 also 5 is the image. For 2 or more elements in A, they have same image in B. This is called what? Many 1 function. Got it? So now we'll see other 2. So now we'll see onto function. So onto function is a function f from a to b is said to be an onto function if the range of f is equal to the codomain, which means codomain is equal to range. Okay, codomain is equal to range. Codomain is equals to range, which means, see, all the elements in the codomain B has its own pre-images in domain A. Okay, so everything has its own pre-images. So this is called what? Onto function. Okay, so then what is into function? Into function is a function f from A to B is called into function if there exists at least one element in B which is not the image of any element in A. So at least one element in a B is not an image of any element in an A. See, for example, I have given here, so A is X, Y and Z and B is L, M, N and O. Okay. See, X belongs to L, Y belongs to M, Z belongs to N. So this is what there is the existence of one element in B which is not an images of A. So one element in a codomain doesn't have any pre-images in domain. Okay, so one element is not matching. So this is called what? Into function. Got it? So now you clearly got what is onto function and into function. See, onto function is also called as surjection. Okay, surjection, like how one is called injection, this is called surjection. Okay, so remember this. Now we'll see what is bijection. Now we'll see what is bijection. See, bijection is nothing but 1 plus onto. When the function is both 1 and onto, that is called bijection. Okay, so this 1 and onto function is also called 1 correspondence. So remember these points. Distinct element A have distinct images in B. So whatever the element you have in A has its own images in B, and even B has its own pre-images in A, which means codomain is equals to range. So this is called what? Bijection. Suppose they have given A is equals to 1, 2, 3 and B is equals to X, Z and Y. So match it. So 1 is equals to X and 2 is equals to Z and 3 is equals to Y. Okay. So every element in A have distinct images in the element B. Okay. So have their own images, and every element in the B have its own pre-images in A, which means codomain is equal to range. Okay, so this is called bijection. Okay, so this is in this video we have seen both representation and types of functions. Okay, so if you have any doubt about this class, please make a notice and let me know this. Okay, so fine. So today's class, that's it. So if you have any doubt, please let me know. Fine, hope this video is helpful for you people. So make use of it. Fine, thank you so much.